Look at the product rule when being used in conjunction with the chain rule. So just a reminder, here's the product rule. So you're going to take the derivative of the g function multiplied by the f function plus the g function times the derivative of the f function. And the chain rule, which is not very technical the way I wrote it, but for me it's the easiest way to understand. Take the derivative of the outside with the inside intact times the derivative of the inside. And here's a quick example problem to help you understand it so you can process it. So we're going to take the derivative of the outside with the inside intact, and we're going to multiply that by the derivative of the inside, which is going to be 3x squared. And there's the chain rule. So we're going to put these two together and we're going to solve an equation. And here's our function, and now we're going to find the derivative. Only we're going to use substitution this time. Now, substitution is optional. It kind of adds more steps, but then it reduces some of the mess. So it's your choice as to whether or not you want to use substitution. When we get into integration, which will be our next topic, I don't think there's any way around substituting without it getting too complicated. So it might be good to get into the habit of using it. But what I did was substituted u in for x cubed plus 1. My finger looks really huge underneath this camera. But anyway, I'm going to go ahead and find the derivative. And again, the f function times the derivative of the g function, which I use the chain rule here, is here's the derivative of the g function, plus the derivative of the f function, which is 3x squared, so that gave us 6x. And then just the g function as it was right from the beginning. Please disregard my error that I made up there. And I went ahead and simplified it for you. Just remember the factored form is the simplest form, so make sure to factor at the end. And that is the product in the chain rule.